Okay, so today we're going to learn about literal equations. Okay, what does that mean? And I feel like I need to have like an iced coffee, Starbucks in my hand when I say we are going to solve literal equations. Okay, guys? It's not that hard. It's literally just solving equations. Okay? We got this. But I find that a lot of people have trouble with this. Oh, ding. A lot of people have trouble with this because it has more than one variable. Okay? There is more than one variable in the equation when we are doing literal equations. Okay? That's when we say literal equations, it means there is more than one variable in it. It is a little bit more complicated. So, to solve means to isolate the variable. That's all that means. Okay? Just remember that when we say solve, it literally means, and I mean literally, means to isolate the variable. So we are using the same rules that we have been doing for solving equations. Same exact rules. So what is that going to look like? So here's our first problem that we're doing. What I did was I gave you what a literal equation would look like, which is this. But then I gave you what is something we know and we know how to do, right? So let's do the one we know how to do first. So we want to solve for x. It says here, solve for x, right? That means we're going to isolate x. That's what that means. Isolate x. It's telling you which variable to isolate. So I'm going to highlight it for both of them. I think it's easiest when we highlight the variable we need to isolate. Well, here we know what we need to do, right? We are going to divide by this number. So when we divide by this number, we get, and this cancels out, and then 12 and 6 you can combine together. So we get 2, and then we get x, right? X equals 2. And we're going to rewrite it because we always want the variable on the left. X equals 2. Pretty simple. Here, however, it's not as simple, but it's the exact same step. I'm going to write this in all caps. Same step. What did we do here? We divided by 6. What are we going to do here? We are going to divide by 6. We want to isolate that variable. So this cancels out. But here's the thing. You cannot combine g and 6. What is g divided by 6? We don't know because we don't know what g is. So the final answer is just that. G over 6 is equal to x. G over 6 is equal to x. Okay, so now what? Now we box our answer. I'm going to rewrite it as x equals g over 6 and call it a day. This is arguably easier because here you have to actually figure out what 12 divided by 6 is. Here you don't. You just rewrite it. G over 6. That's it. You can't rewrite 12 over 6. You have to do 12 divided by 6. Here, you literally just take the g over 6 and rewrite it. All right, let's try another one. U equals 2x minus 2. So I'm going to rewrite something that we know how to do, right? What do we know how to do? We know how to do, let's say, 4 equals 2x minus 2. What is our first step? Our first step is to add 2, right? And then we get 6 equals 2x. And then what do? We divide by 2. And then we get 3 equals x, or x equals 3. Right? Now let's look at how we're going to do the exact same steps. But instead of this 4, we have a u. Okay, so we cannot combine. So I'm going to highlight first. It's asking me to solve, right, for x. You see that 4x? So I'm going to highlight my x. That is what I want to get by itself. The end goal is to get x equals something. So notice how we're going to use the same steps. I'm going to add 2 plus 2 to both sides. So what do I get? I get u plus 2. I cannot combine these, so I'm literally going to rewrite u plus 2 equals 2x. This goes away. We crossed it out. Now what do? What did I do here? I'm dividing by 2. Again, we are solving for this x, so we need to get rid of all its surroundings. So I'm dividing the entire side by 2. And so what do I get? This goes away. Let's be consistent with our colors, Miss Masood. And then I get, on this side, I get x plus 2 over 2 equals x. Ooh, not x plus 2, u plus 2. U plus 2 over 2. Notice how the entire thing is over 2 because I'm dividing the entire side by 2. And the final answer, I'm just always going to rewrite it with my x on the left. X equals u plus 2 divided by 2. Final answer. Again, it's the same steps, except we don't know what u is, so we cannot combine the numbers together. Let's try another one. Here we have z equals m minus x. What are we solving for? We are solving for x. So let's put some numbers in here so we could pretend like it's something with numbers, right? So if I had 8 equals 5 minus x, what is the first thing I would do? Well, the first thing I would do is I want to get rid of this 5 because I'm solving for x. It tells me what I'm solving for. So I'm solving for x. So the first thing I'm going to do is subtract this 5 out. I want to get rid of that 5. What do I end up getting? Right, this goes away. So what do I end up getting? 8 minus 5 is 3 equals negative x. Again, I'm solving for x. So what do I have to do? I have to divide by, what's technically this number right here? It is technically a negative 1. So I'm going to divide by negative 1. So I'm going to divide by negative 1. And so I get 3 divided by negative 1 is negative 3 equals x, or x equals negative 3. So, same steps. You will notice we are doing the same thing, except instead of a 5, it's an m, and instead of an 8, it's a z. So, the first thing I'm going to do is I'm going to subtract this m out, minus m. Okay, so I get, this goes away, so I get z minus m equals negative x. Then I need to still isolate x by itself, so I need to divide out this negative 1. This is still a negative 1. So I divide out a negative 1. Now when I divide by negative 1 here, what happened? This became negative, right? 3 divided by negative 1 is just negative 3. So when you divide or multiply something by negative 1, it just turns everything negative. So when we divide two numbers that are being added or subtracted together, what I like to call the heart method is you divide this by it and this by it, that same number. So what I'm going to do is I'm going to rewrite this. I'm going to rewrite this as z divided by negative 1 minus m divided by negative 1, or negative m divided by negative 1, right? Equals, this went away, so we have x. So what are we going to do? We're just going to make everything negative. So this becomes a negative z and a positive m equals x, but we always want to make it so it's alphabetical. So it's going to be m minus z equals x, or x equals m minus z. Okay? Okay, we're going to do one more. Here's the prompt. It's this one right here. Now we are solving for a. Now I did one here to kind of go over what to do when you have certain things going on. Now, the first thing we want to do in this problem, we're going to do the one with the numbers first, is how do we undo division? Well, you do the opposite. We're going to multiply. So I'm multiplying the entire side by 3. This goes away. So what do I get? I get 12 equals 2a And what do I do to undo this multiplication? I divide by 2, and I get, this goes away, right? The 2 goes away, and I get 12 divided by 2 is 6 equals A, or A equals 6. Now let's try this side. So the first, again, same steps. To undo the division, we are solving for A. So to undo the division, we're going to multiply whatever's on the bottom. So I'm multiplying whatever's on the bottom here. This goes away. So I get here, B times U is BU. Okay? Equals AK. Walk. And then, again, I want to get A by itself. A and K are being multiplied together. So I'm going to divide by what? I want to get rid of whatever's with A, so I'm going to divide by K to get A by itself. And what you do to one side, you do to the other. So I get BU over K is equal to A. Or, again, we write it when A is by itself. A is equal to BU over K.